Hello, today we'll talk about chapter 6.2. Okay, so and definitely integral. Indefinite integral. First, look at the definition. The family of all antiderivative of function fx in indefinite integral of x with respect to x denoted by integral fx dx. One more line. If f is any function such that f prime x fx, then integral fx dx equal fx plus c. C is arbitrary constant. Okay, what they mean by that? We talked about before a lot. Just review. So something come out when you derivative. We can say maybe 2x. Okay, is possible x squared plus 1, 2, 3, right? Whatever. Because plus c, and this is 0, right? It's going to 0. So we don't care this number. So simply c arbitrary constant will be c. Okay. Before, if they give lower limit, upper limit, we can find the exact number of c. But they don't given, which means we don't know. That's why they call indefinitely integral, right? So we look at the example. So they have integral x squared sine x. So kind of recall, what come out x squared is supposed to be what? Something integral. So it should be x cubed, right? Over 3. When derivative 3 come out and numerator and denominator 3 just cancel each other, which means 3 over 3, right? And plus c. Because we don't care any number, so it's arbitrary constant, right? How about sine x? Something sine x negative is supposed to be what? Cosine x derivative come out sine x, right? So finally we can have x squared plus subtract sine x dx. So x squared is supposed to be what? X cubed over 3 and sine minus sine plus cosine x plus c, right? So with c arbitrary constant, this one indefinitely integral, right? Okay, next page, page 332, there's a property. So indefinite integral, power, or trigonometry, and exponent. I think you should memorize, kind of have no option. So this part, I think you will be okay. Power function I mentioned, the same problem. See, negative 1 should be changed in upper reciprocal, which means log, ln. We're going to deal with example 2. How about trigonometry? So cosine, sine, negative cosine, secant square, tangent. Cosecant square, negative cotangent. Secant, tangent, secant. Cosecant, cotangent, negative cosecant, right? And exponent, exponent will be fine. But if a base will be not e, like constant number, you should change that form. Okay, just remember, right? So AU over ln How about here? ln U. Also U ln negative U plus C. Okay, this one also probably later, kind of familiar, but didn't mention right now. This is later we're gonna talk about. How about here? Not natural log, just log. We change to change base using natural log. So this one looks like it's just what? Constant, only numerator from the here. Okay, this is sorry for that, you should memorize anyway. Okay, All right, next one, problem 2. Just verify antiderivative formula. So first one, A, u negative 1 power, which means 1 over u. How come ln u? C. So which means we're gonna do this direction. Is true or not? Okay, but this is absolute value, so we should check what positive, negative, right? The first one, maybe u when u is positive, okay, which means ln u is positive. This one derivative. You remember this is 1 over u n plus c. Okay, so another plus c here, this derivative, and this is going to be 0. Okay, so it will be 1 over u. Okay, so one more time, when you make the c means integral, but derivative just going to 0. Okay, how about if u is negative, which means absolute value going to negative, so ln parenthesis negative u plus c, this one derivative, so it will be what, 1 over negative u times derivative for negative u will be negative 1 plus 0, which is 1 over u, right? So conclusively, which means ln negative u absolute value plus c derivative will be 1 of u. Okay, so which means integral 1 over u du will be ln absolute u plus c. Alright, understand? Alright, next one. Yeah, formula that you mentioned there, right? So how we can get this one too? So also we're gonna using antiderivative way, which means u ln u minus u plus c derivative. So this one, what? Product rule, right? U, maybe first one, second one, doesn't matter. U 1 times ln u plus u leave here, ln u means 1 over u, and negative 1 is going to be 0, right? So leave here ln u and plus this one going to be 1 plus, right? And this one negative 1 will be, it's going to be 0 too, right? So finally ln u. So come here. So finally integral ln u du equal to u ln u minus u plus c. Okay, this verify. Right? Okay. Right. One more problem. Unit 3. A little confused, but just step by step, probably be okay. So first of A, try. Well, before fx they given x cubed plus 1, u is x squared. Okay, so think about the respect to x, respect to u, respect to x. Okay, same xx, same uu. This ux is different, right? It looks like a similar problem. It looks totally different. A1, first one, integral fx will be the given x cubed plus 1 and dx. X cubed integral what? X fourths divided by 4 plus x plus c. Okay, I think A will be okay. A will be pretty easy. B integral fu. So f function here, u, right? You just plug in there, right? So x cubed x. So they change. Oh, sorry. This is u. So it will be just f. U will be x. U cube plus 1. Okay. So u cube plus 1 du. Same method. U force 4 plus x and u plus c, right? But they said what? In terms of x. So change x. So u force now plug in. So x square force 4 plus x square plus c, which means x8 or 4 plus x square plus c. Okay, and c now is ux different, which is plug in. So integral. So before fu means x square cube plus 1, okay, which means x6 plus 1, okay, that is plugged in here, right? So here x6 plus 1 dx, which means x7's power over 7 plus x plus c. Okay, so you can see that, right? And it's totally different. You see that? This answer is different. You see that? Okay. Alright. Next one. Okay, evaluate. Okay, so in this case, a substitutional method. So we're gonna using substitutional a little differently. So which means kind of chain rule. So whenever this value derivative here, we can substitute, which means simply maybe u. So u will be cosine x and du, this is derivative, minus sine x dx. Right, you can see that, right? So we're gonna substitute. So original function equal to, so e cosine x will be e, okay, just write down one more time, x and sine x dx. Okay, so e cosine means eu, and we need a negative sign, so make a negative sign in front, and just du. Okay, so eu means integral just to negative e u plus c. And what's the u? Negative e cosine x plus c, right? So simply we substitute, okay? Substitute, kind of chain rule, right? Find the answer. Understand? Maybe one more, okay? So, okay, here we're trying to match which number should we come out some number after the derivative. Looks like, right? Looks like you can see that, right? This number kind of match here. So which means, so u equal 5 plus 2x cubed, right? So du, when you derivative, this one will be 6x squared dx. One more maybe. Du over 6 will be x squared dx. Can you see that? So, maybe a different color try. Alright. Okay. So, derivative. So, make match here. So, 5 plus 2x squared and x squared dx. Right? So, 5 plus 2x will be u, right? So, square root u, and this one going to be du over 6. Okay? But this is 1 over 2. So, okay, one more time. U 1 over 2 du 6. So we change 1 over 6 come out to third u 3 over 2 plus c. And the u means here, right? So simply plug in that. So 1 over 6 5 plus 2x cubed 0 over 2 plus c. You see that? Okay. Pretty simple, right? Substitution way. Right? Are you okay? Maybe try one more. Otherwise, little trigonometry. Maybe trigonometry is next time. All right. Okay, question. Let me know. All right. Thank you. Bye bye.